Oh,
single one.
so because I noticed you had another one.
It's the same. Yeah, I uploaded twice just
Oh,
for the
okay.
sake of.
Okay.
So
Yes, one.
okay.
Yeah, we're back to
Hello everyone. Today we'll present this idea of using to improve latency on CPU isolation without incurring much cost. I mean, it's a continuation of a presentation that I had last year at the same conference. This is me. I work at Red Hat, improving CPU isolation, live migration, trying to reduce overall guest latency. And also host latency as well, because it's necessary as well. You can find me over this handle on those networks. Well, what we want to run time-sensitive tasks with very low latency. That's the idea. So we can enable more real-time workloads on Linux. One way of doing this is trying to have this real-time task to run as uninterrupted as possible. Because, if it's running, if it's not scheduled or the CPU is not on interruption, there is more time to process. I mean, more, it's ready to respond. So it's faster. I mean, it will have less latency. One of those issues that we have to deal with is having interruptions on the CPU that's running the real-time workload, because, it increases the latency of the workload because it may take time to process the interruption, and at this time the workload won't be able to reply whatever request that is forwarded to it. So one of those interruptions is called by interprocess interruptions. We like the ones inserted by schedule work on and queue work on. As of today, we can put some of those interruptions in housekeeping CPUs with CPU isolation, which is great. But there are some of them which we are not yet able to avoid. So what can we do about it? For explaining that part, I will try to introduce this problem which happens in some parts of the kernel. I see that on memcg, slub, and swap. But the idea is that you have a per CPU cache, which is quite efficient. The idea is that you are mostly touching this resource on per CPU granularity, and whenever some CPU needs more resource and you're trying to clean the cache that those other CPUs have, you will incur an IPI. It's great because you are mostly operating on local cache, and you don't have to use atomics or grab locks, like regular locks on that. But the reclaiming of resources from remote CPUs incurs an IPI, and if your processor who is running this real-time test receives this IPI, it will incur latency, which we don't want. That's the general idea of such per CPU cache. The idea is that the hot path, you just grab local locks, do your local work, and then local unlock. And when you eventually need to do this remote drain, for example, you just schedule work on every other CPU that's online. But as I said, that generates an IPI, and that's bad for the latency on that CPU. So how can we get rid of this IPI? I mean, not every situation can be done. I mean, sometimes you want to mess with hardware registers and hardware resources, so you can do this every time. But for those three applications that I mentioned before, you can just, for example, replace local locks with per CPU spin locks, which is the topic of my last presentation. So you get this per CPU spin lock for a CPU when you want to operate locally, and when you rarely happen to request an operation on a remote CPU, we just grab that remote per CPU spin lock and do the work anyway. And since this operation, like this remote operation, doesn't happen very often, you almost have no contention. There is some work that's done in this way by Mel Gorman on this commit that I mentioned here, where he successfully replaced local locks with per CPU spin locks and got some performance and latency improvements. And the whole idea of this replacement is like this. You replace local locks per spin locks, and then instead of running scheduler call, you just grab the lock, the per CPU lock, and do the work that you need. As mentioned before, the whole idea of spin locks is that they are expensive for three main reasons. Contention, getting cache line exclusiveness because you have to transit this cache line between CPUs, and memory barriers, which is the less of them. But in this case, in this per CPU cache case, you don't have a lot of contention because the drain operations are very rare. Getting cache line exclusivity is also very common. I mean, you are mostly having this local per CPU cache line exclusivity because you are mostly operating in your local CPU data. And the memory barriers are not supposed to be that much expensive at this point. But in any case, using the per CPU spin locks, we'll introduce like extra 3 to 15 cycles, depending on you inlining or not the spin lock call. And for some hot paths, that may be too much. But there is some point. When we enable preempt RT, we already have per CPU spin locks for local locks. So this price that we pay at the local lock grabbing and local unlock, it's already paid. So why not? Let me see. Why not get the remote spin lock and do that anyway? So it's already using a per CPU spin lock. It's just using for its own CPU, but we could just grab that spin lock and do the work that we need. That's where I introduced this idea. The naming may be not final at this point because, well, but the idea is that we can queue per CPU work. And this interface is supposed to keep the things working the same way on preempt RT disabled, and apply this new strategy of per CPU spin locks on the preempt RT enabled. As I said before, when it applies, because hardware, things that touch hardware, that can't be done. But creating an interface for that is kind of messy. But we need to have this new helper to request and to flush the work when we need it. And also, we have to have a new way of getting the other CPUs, like the remote CPUs, local lock at this point, because it's kind of messy if you just like, well, remote lock of this CPU. So that's where I introduced this idea of QPW, which means Q per CPU, right? Work. The idea here is that we replace the local locks with these QPW locks and use this per CPU spin lock strategy to that you use the strategy of using the spin lock that's already available on local locks with preempt enable. And this Q per CPU work will mostly grab the CPU, as I mentioned before. I mean, the idea of replacing it just happens here, like in line for preempt RT equals yes. On the preempt RT equals no, it will just fall back to the current functions. Those are the structures and functions, the idea of those functions that I just mentioned. You have just to create a new QPW struct to hold both the work struct and the CPU that you want to request work from. the QPW lock is just a spin lock when parameter RT equals yes. So the unlock is the same thing, and then you just grab the work structure and run the function. The flushing is nothing because you're already doing all the work. So it would vanish with some bugs, such as this one, where we grab, the CPU was very busy, and for some reason the flush work got stuck. Since the flush work in this implementation does basically nothing, this kind of bug will just go away. The implementation of this is like replacing, for the first example, we just used QPW lock instead of local lock, and Q per CPU work on instead of schedule work on or Q work on. Then I sent this implementation on the mailing list. On those, and I implemented the QPW and applied it on mem controls, lub and swap, and tested it to find that it actually was very able to reduce the latency that we experienced on these virtual machines, and also in the host. The advantage of this implementation, where we just have to manually select the applications that will be using this and converting everything, it's just that we can convert uses on demand. And it doesn't mess with other users, but when we have to convert it, it may take a while, because if you're running a function on this Q per CPU work on, you have to convert it so you are not using local locks, because if you, in this context, grab a local lock and you are intended to grab the remote CPU's lock, that will be just messy. So we have to go through this case with a lot of caution. We have to analyze what will be called, and it's kind of hard to do that. So I was talking with some colleagues at Red Hat, and this idea came on, the idea of emulating the DCPU and SMP processor ID. Yeah, it's kind of hard, but it's a little bit better, I mean, for converting those previous usages, because we just replaced the Q work on with Q per CPU work on.
How much do you have?
Sorry?
How much do you have?
How much?
How much slides do you have to go on?
Right.
How much maybe like?
Oh, it's just that, almost.
Okay.
Sure.
In RT, in the early days, we had local log on, which is basically
Yeah.
what you suggest. We had, I have no idea, 20, 30 users in total. And then I started cleaning up, and we got down to C group and MM. Mm-hmm. And I didn't get around with MM folks and C group to get cross CPU access. They didn't like it at all. Mm-hmm. And this is actually the only reason why we ended up with local log or mainline. Mm-hmm. And over the years, I managed to get them all done, and except for MM, because of the latency you had. Mm-hmm. Because like memory accounting, it was hard. And it doesn't matter if it's networking or other subsystem, all of them appreciated having the same implementation for RT and non-RT. Yeah. But this, if you go into this way, you're going to break it. Yeah. Next thing is, it's not only RT. No-heads full is having the same limitation. They will also want this if you go that way. Mm-hmm. I think in the long run, you will be better off if you would transform them manually one by one, if the upstream maintainer appreciates that, to have cross-CPU access instead of doing it locally.
Okay, so you're suggesting that the previous idea of changing the whole implementation of local locks plus API to just spin locks would be better than just using this?
Yes, this is what I've been doing case by case, across the kernel.
I see.
And if it wouldn't be for MM and C group, you wouldn't have it today.
I see, yeah. Yeah, I tried to do that like a couple of years ago, to try to convince people from MemCG to migrate the caches from like local to per CPU spin locks, but that didn't go well. They didn't like the latency that was introduced.
It was me years ago, yes.
Yeah, okay. I can try that again then.
But if you go and emulate SMP processor ID and this CPU, and then you have migrate disable somewhere in between, this is getting messy.
kinda, yeah. But the idea is to create an option for the neck that I take before and actually try to fix this. This is a lot of work, I agree, but...
How many
that
users
fix-
do you have?
Sorry?
How many users do you have?
I found those 3. I suppose there are more. For like, not just for I mean, I picked the per CPU cache idea, the local log plus API, but the idea of this QPW is that it could replace any QR cone that does not touch hardware. So we could potentially save a lot of APIs on the per CPU. Sorry, in the real-time running CPU.
Right, okay.
So it just created an opportunity. Maybe there are not that many scheduler con or QR con. So maybe it's not that good, but I think it's worth to try because that would remove a lot of APIs at the same point.
To give another example, we had VM-stat earlier, which was scheduled on each and every CPU, and it had to be that way. But then MM folks were on the other side that we could skip it, and now this is gone. VM-stat was one of those workers which was scheduled on every CPU every now and then regularly to update statistics or something like that. And then we talked to them and they agreed that we could slide. And it's not happening anymore. Only on those active CPUs, no longer on the isolated ones.
I see.
So maybe you're saying that we first want to confirm that we cannot really just remove the thing before. I mean, the 3 use cases. Just confirm that they are really needed.
Yes, because it's not just RT, just no heads full should also.
Yeah, no
Use the
hurts full
same
to
boot.
use this feature would require preempt RT because or else we are introducing spin locks the same way. So
Okay.
well, I was just saying the advantages of like emulating the CPU number would be to don't have to touch every case by itself. We would just make to work on the helpers and emulate the CPU number. But the disadvantage is that
Yeah, it's just a quick comment actually.
Sure.
So like the APIs, I mean, this is from the RT context, but I've seen APIs actually being a source of noise from CPU idle as well. So like this work is actually could be interesting beyond RT. So like making these things available outside of preempt RT only, I think there will be interest in it because like APIs, I've seen a lot of APIs just waking idle CPUs from deeper idle states and they are very hard to track. And what you are doing here is probably part of the cause, although I've seen the work queues as well, especially with the new CM queues. It seems they have a scheduler of their mind where it decides what CPU to wake up. But this work would be very interesting as well outside of RT for power management, especially CPU idle management. So
Yeah,
like
we
making this
could,
available would be quite
yeah.
great. Yeah.
But yeah, we could try to add an option and try to enable it without RT as well. And it would cost us the CPU lock and the spin lock and the spin lock. But if it's interesting in some case, that the person could enable it in like command line or so. Thanks.
Would it be automatically enabled for no hertz full then?
Yeah, we could, but they would have to pay the price, right? That's spin lock
There's
price.
there's already a performance hit when you enable it.
Yeah. That what I was talking next. The option of enable and disable it in like
Yeah,
both
just
parameters.
oh, you have 7 minutes left. So just,
To the next one. Okay. no
if it's up to you.
Sure. Then that's the slide where I would ask more suggestions if someone has anything, please, on this work.
Nope.
Nope. Well, thanks everyone. I will just jump to the next one. It's right here.
Oh.
Thanks.